Good morning, Trick fans. How are you on this fine, sunny Monday morning? Yes, it is Monday morning. It is a beautiful day outside. It's supposed to get around 60 degrees out. I suggest go out and enjoy a little bit of nice weather out there. Remember, keep your social distancing though. But go out and enjoy some weather. Maybe go out to clean out the flower beds for your mom or dad. How's that sound? Do something like that, do a little something outside, but also please do get your trig homework done and all the rest of your schoolwork done. Please get that done also. It is Monday. I hope everything is going well in your household. I hope everybody's feeling well in your household. We're going to continue on with the angle with identities, but once again we're going to just be dealing more of just application rather than proving any type of trig identities. Those that have not completed the work from last week, please get that completed and turn it to me. Once again, you can either email me a picture or scan it or send it through Google Classroom. Whatever works for you, that is fine with me. The ones that have submitted, I have graded and I have posted on a progress book your grades with respect to those. So please keep on continuing to work through that. The evaluation starts this week. I will go through some notes. I have 5 questions for you to do then on Google Classroom. Those are multiple choice. Some problems to work out with respect to what we're going to work with today. Today we're going to continue with, once again, the identity ideas. And feel free to use your notes as you're going through any type of the work that we're doing here, because these formulas, I usually provide an index card, or have the students do an index card with all the trig identities that we've gone through. So feel free to just use your notes and pull the information off of the notes with regards to the trig identities, or if you want to get a list of them, that's fine also. I will also post a list that I have in regards to all the trig formulas that we have. I will post that also that you can print off and utilize too. It's sort of a condensed way of being able to utilize all these trig formulas that we will be going through. Today we're going to start talking and working with the idea of a double angle. When we have double angles, what does it mean mathematically? How do we double an angle? How do we double a quantity? If you have say you have $10, and I'm going to ask you to double that $10. I'm going to ask you to double the $10. Okay, how do we double the $10? Well, we double that $10 by either adding another $10 to it or multiplying it by 2. So we could take our $10, and when we double it, we could take the $10 and add another $10 to it to give me $20, or we could take the $10 and multiply it by 2. Both of those are acceptable ways of saying that we're going to double a quantity. So we're going to double our angles now. Well, when I have a doubled angle, that means I just have 2 times the angle. Well, let's take it out of this realm here into this realm. How else can we rewrite the sine of 2a? Well, that would be the sine of a plus a. Well, what we just went through is a bunch of angle additions last week, where we had the sine of a plus b, the cosine of a plus b, and the tangent of a plus b. Now, whoopsie, what I want to be able to do, I'm sorry about that, is do the sine of a plus a. So as you expand out the trig formula, sine of a plus b, all we have is an a and an a. We don't have a b there anymore, we have an a and an a. So what we're left with is the sine of a times the cosine. Well, what we had before was this cosine of b. But now we have the cosine of a plus the cosine of a times the sine of a. Once again, we're just taking the b out. We're saying bye-bye to the b and replacing it with another a. Well, mathematically, we have what's called the commutative property, which means if I have x times y, this is the same as y times x. 2 times 3 is equal to 3 times 2. Okay, that's the commutative property. So over here, I can rewrite this as the sine of A times the cosine of A, plus I can flip these two around, the sine of A times the cosine of A. So I have sine A cosine A plus another sine A cosine A. Now I'm going to ask you to use your algebraic skills. If I have x plus x, we come up with 2x, because we add the coefficients. Well, if we have xy plus another xy, what are we going to come up with there? Well, you're exactly correct, 2xy. So we have 2xy. Well, now we have switched the x and y's to cosine A sine A. So I have sine A cosine A plus another sine A cosine A. What does this equal? This equals 2 sine A times the cosine of A. And this is the sine of 2A. Another one of those formulas. Just as last week we expanded out sine and cosine of angle addition. Now we have sine and cosine of double angles. So this is one that you will have to apply. Well, what happens when we have the cosine of A, or 2A? Once again, this is the cosine, oopsie, tartar sauce. This is the cosine of A plus A. Okay, what I want you to do is I want you to expand that out using the cosine of angle addition. Okay, so good. Hit your pause button, expand that out, and then turn it back on. Well, what this will give us is this will give us the cosine of A times the cosine of A minus the sine of A times the sine of A. Now we have to go back to what does it mean when I have something multiplied by itself. When I have x plus x, that gives me 2x. When I have x times x, that gives me x squared. Well, what we have with this is the cosine of A squared minus the sine of A squared. But when you're dealing with the trig and you're squaring the entire quantity, this tells me I take the cosine of A. Whatever that cosine of A is, I square it. Whatever the sine of A is, I square that. Well, how they write that in a more acceptable mathematical form is cosine squared A minus sine squared A. That is the cosine of a double angle. Now, the one thing we do have, though, is if you remember back last week when we started dealing with trig identities, we had a couple little things that dealt with cosine squared and sine squared. If you remember back, sine squared of A plus the cosine squared of A is equal to the value of 1. If we manipulated this, we could subtract our cosine squared from both sides. So we have sine squared A is equal to 1 minus cosine squared of A. And if you remember back, what the basis of all trig identities is that substitution principle, replacing something with its equal. So rather than writing the sine squared here, I'm going to replace it with 1 minus cosine squared. So we have cosine squared of A minus, now I need to make sure I get my parentheses in here, 1 minus cosine squared of A. And once again, if I'm going too fast, hit your pause button. I will not talk through the pause button. Okay, I will shut up as you catch up. Then you hit the play button again. So if I use my distributive property, we have cosine squared of A minus 1 plus another cosine squared of A. Well, now we have cosine squared A plus another cosine squared A. Well, I have this plus this. This gives me 2 cosine squared of A minus 1. So this is another double angle formula. This is more used when we try to deal with proving some trig identities a little bit more. You can use it as a substitution when you get into upper level mathematics also. We utilize this formula. Likewise over here, I could have subtracted the sine squared over. So we have cosine squared of A is equal to 1 minus sine squared of A. And we could take this value here and sub it in up here. So what this would look like is, let's see here. 1 minus sine squared of A minus another sine squared of A. If I have minus sine squared, that gives me 2 minus sine squareds. So we have cosine of 2A is equal to 1 minus 2 sine squared of A. So what we have is we have 3 different formulas that deal with the cosine of a double angle. What I would suggest you use, this one right here, because that would make your calculations a lot easier when we go to simplified calculations. Because what we have is we will come up with a common denominator, and it's a little bit easier to work with fraction-wise. Okay, tangent of 2A, which is tangent of A plus A. Now what I want you to do, once again, is I want you to expand this out, okay? I want you to expand it out, see what you come up with, because you use a lot of these different ideas that we've talked about up here. Expand it out and try to combine it together. See what you come up with. So hit your pause button, do that, and then turn it back on and check your answer to make sure we have things correctly. Go at it. So this is the tangent of A plus the tangent of A over 1 minus tangent of A times the tangent of A. Well, when we have tangent A plus tangent A, that gives me 2 tangent of A. On the bottom, we have 1 minus tangent squared A, where we have tangent A times the tangent of A. So our tangent of 2A is equal to this. Once again, we could do reciprocal functions. If I wanted to do the secant of 2A, this is just 1 over the cosine of 2A, and so on. The sine of 2, or cosecant 2A is equal to 1 over sine 2A, and the cotangent of 2A is equal to 1 over tangent 2A. So we can do our reciprocal functions there also. Alright, let's work through some problems now. We are in quadrant number 3. The tangent of angle A is negative 4/3. I'm sorry, it's 4/3. And we want to find the sine, cosine, tangent of 2A. Okay, now, first thing we do is, like always, draw a picture, draw a picture, draw a picture. So let's draw our picture. Let's get our angle in quadrant number 3. The tangent is 4 over 3. This is opposite over adjacent. So we have 4 over 3. Means our hypotenuse using our Pythagorean triples is a value of 5. But we are going left and we are going downwards, so we need to make sure we throw negatives in there. So we want to find the sine of 2A. Well, first we expand this out to sine of A times the cosine of A. So we have 2 times, I need to look up on my triangle and find my 2 ratios. So what is the sine of angle A up there? That's exactly correct, -4 over 5. Going opposite over hypotenuse. What is the cosine of our angle up there? You're right again, -3 over 5. So what we have is we have 3 fractions that we have to multiply. Multiplying fractions, we multiply across the top, multiply across the bottom. So we have 2 times -4, which is -8 times -3. So we have 24 on top. 1 times 5 times 5 is 25 on the bottom. These are a little bit easier than the angle addition ones. Cosine of 2a is, I would suggest, once again, is using this formula because we're going to be squaring fractions and we have hypotenuse on the ratio of both of these in the bottom, so that's going to give me a common denominator. So we are finding these ratios, the cosine of A, which we already did, -3 over 5, and the sine of A, which is once again -4 over 5. Now you just have to really watch. I'm squaring negatives. That's going to give me positive. So we have 9 over 25. And -4 squared is 16 over 25. So we have 9 minus 16 over 25. Or -7 over 25. Tangent to A is 2 tangent A over 1 minus tangent squared of A. Well, what I would do is I would probably take the tangent of A being 4/3, because it's -4 over -3, so it gives me positive 4/3. So we have 2 times 4 over 3 and 1 minus 4 over 3 squared. Once again, using your calculator, on top, I would first do a little bit of mental math. We have 8 over 3 on top. 2 times 4 is 8 over 3. On the bottom, we have 1 minus 16 over 9. Now, if you would quantify both of those, you could do this all in your calculator. So we have 8/3. And once again, take it back into a fraction for me. So we have quantity 8 divided by 3 divided by 1 minus 16 divided by 9. And my quantity out. I want to take it back into a fraction. Hit my math button, hit enter, hit, oh. Oh, I gotta try this again. Let's see, parenthesis, 8 divided by 3, and parenthesis, divided by parenthesis, 1 minus 16 divided by 9, and parenthesis, hit my math button, hit enter. Oh, that was weird. Oh, it'd be nice if I could use my own calculator. Try it one more time. Take 3, parenthesis, 8 divided by 3. divided by parenthesis 1 minus 16 divided by 9 end parenthesis. Hit your math button, hit enter, Yay! Boo, boo, boo. Boo, boo, boo. I got the right answer, negative 24 over 7. So we have negative 24 over 7. There we go. Took me 3 times, but I got it. KYC, no moment calculator. Let's take a look at the last one. I'm going to change this to a value of 2. I just want to solve for my general solutions. So we have 2 sine theta cosine theta is equal to 1/2. So what we want to do is look at the right hand side. What on the right hand side looks like this and take it back to the left. So if we scan through, what we're left with is a sine of 2 theta is equal to 1/2. Taking the inverse sine, once again, we should become a little bit more common. It's something we've done quite a few times. You should be a little more comfortable with it. So we're left at 2 theta is equal to 30, but then we also have to worry about the supplement. So we have 2 theta is equal to 150 degrees. We can divide by 2, by 2, by 2, by 2. So theta is equal to 15 plus or minus. Here theta is equal to 75 plus or minus. Now, what we have created here is we have created this b value is equal to 2. So what we have as a period is 360 divided by 2, or 180, 180, and 180n. So there is our solutions to solving the equation. If you have any questions, once again, feel free to comment, send me a question. I'll try to get back to you as quickly as possible. I did give you 5 questions to do, to work through. Basically, you're finding sine, cosine, tangent, double angles, doing one equation, and I had one additional question in there for you. So go ahead and work yourself through the problems. Other than that, if you haven't done last week's work and evaluations last week, please get them done and completed and get them turned into me as soon as possible. Once again, we have to continue to work ourselves through this. Enjoy some of the sunny, nice, warm weather here. Keep your social distancing out there, and have a great day. Bye. I miss you guys.